Isotopes. Isotopes are atoms of the same element with the same atomic number but different mass numbers. Think of it this way. What is mass number? It is the sum of the protons and neutrons. And the number of protons is what we call the atomic number. This shows us that if two atoms of the same element contain different mass numbers but the same atomic number, then the difference must be in the neutrons. Those two atoms of the same element contain different number of neutrons. Let us use an example to understand this. Isotopes of hydrogen. The first isotope of hydrogen is hydrogen 1, the one that we usually talk about. These two numbers represent the atomic number and mass number. The number above represents the mass number, while the one below, if you can remember, represents the atomic number. The second isotope is hydrogen 2 or deuterium. Notice that the mass number is 2 this time instead of 1. That means deuterium has got 1 proton and 1 neutron to give us a mass number of 1 plus 1, which is equals to 2. The next isotope of hydrogen is tritium or hydrogen 3. Again, notice that the mass number is different. That means deuterium has got 1 proton and 2 neutrons to give us a mass number of 3. Next, we have another example of the isotopes of carbon. The first one is known as carbon 12 and the second is known as carbon 14. How many neutrons does carbon 12 have? And how many neutrons does carbon 14 have? Spend some time to calculate. More examples of isotopes include the isotopes of oxygen, which we have oxygen 16, oxygen 17, and oxygen 18. Again, calculate the number of neutrons in each of these isotopes. The next example is isotopes of chlorine. We have chlorine 35 and chlorine 37. Again, you need to calculate the number of neutrons in each isotope.